Hello, Math 7 students. So we have a couple weeks left, and what I want to do is pretty much teach you two last concepts in seventh grade. One is how to solve a two-step equation, and the other one is combining like terms and distributive property, which you probably remember from last year. So anyway, let's start off with solving two-step equations. When solving two-step equations that have more than one operation, you got to do the order of operations backwards. So parentheses, exponent, multiply, divide, add, and subtract become, well, you got to, you know, undo adding and subtracting first, and then you would worry about multiplying, dividing. I'm going to not worry about the exponent part right now. That's something that you could do at another time. So I'm just going to keep it pretty basic for today. Um, so anyway, the steps when you're solving a two-step equation is identify the variable. If you want to highlight it, highlight it. Draw a divider at the equal sign, and then you want to undo, add, and subtract first on each side. Then you want to undo, multiply, and divide second. And when I say undo, that means you do the inverse operation. So if you see adding, the inverse would be subtract. If you see multiply, the inverse would be divide, and then vice versa. And then you could always plug in and check your answer, okay? So another definition I want you to be familiar with is something called a tape diagram, and that's a visual representation of an equation. So this right here is a tape diagram. Let me cover this up. So it's saying reaching from left to right, all these boxes together equal 35. This whole thing equals 35. 8 is what one of the boxes, this is considered a given. This is given that this box represents 8 of the 35. But we don't know how much each x is, because this is called our unknown. But we do know that each x is going to be equivalent to each other x. So if one x is 3, all of these would be 3, right? Now you could sit here and guess and check. I mean, let's go like 2, for example. If you could say 2, 4, 6, 8, 10, 12, 12 plus 8 is 20. Nope, that doesn't equal 35. So then you can go 3. 3, 6, 9, 12, 15, 18, and then 18 plus 8 is not going to equal 35 either. That, that eventually will give you the answer. Or a better strategy is setting up an equation. Well, what do we know? We know that 8 plus, how many x's do we have? 1, 2, 3, 4, 5, 6 x's, and you write that as 6x equals 35. I know that has to be true. Okay, so let's look at some possibilities. Which of these match? Let me change the color here. Which of these equations also match what I have here in blue? Well, 35 equals 8 plus 1, 2, 3, 4, 5, 6 x's. Is that true? Yeah, it is. So I know that one would be considered true. What about this one? 35 equals 8 plus 6x. Isn't that the same thing as what I have here, just flipped around? So that one has to be true too. What about 6 plus 8x equals 35? Well, are there 8x's? No, so that's not true. What about 6x plus 8 equals 35? Am I able to use the commutative property to flip those around? Yeah, that's true. I mean, the idea there is like, what's 2 plus 5 equal? Well, that equals 7. What's 5 plus 2 equal? Well, that equals 7. So the commutative property says you can switch around your terms as long as you're multiplying or adding. Okay. What about 6x plus 8x equal 35x? Well, that's not true. 8 isn't 8x's. It's just 1 8. And then the last one is 35 minus 8 equals 6x. Let's see, 35 minus 8 equals 6x. I don't think that one's true either, All right, so what I want to do is figure out what this would be. Now, I'm going to give you notes on this, and so identify the variable. So let's go back. The variable is x. I'm going to highlight that. So I know I got to get x by itself, right? And then the next step is draw a divider between on the equal sign. So there's my divider. What I do on one side, I have to do on the other. So my first step is going to be undo adding and subtracting. I got to get rid of this positive 8. What's the inverse of a positive 8? That would be negative 8. So I'm going to subtract 8 on both sides. This is just like the one-step equations that we were doing, except now you're going to do 2. You're going to do back-to-back. Okay. Maybe I can make that black. Let's see if that looks better. There we go. Okay. So let's clean it up. What are we left with when we have this 0 out? Again, this is going to 0 out. Well, we're left with 6x equals 35 minus 8 is 27. All right. All right, and then I have 6 times x. So the opposite of multiply by 6 is going to be divide by 6. So I'm going to show that with a fraction bar. So we're going to divide by 6 on both sides. I get x equals, and the answer is going to be 27 over 6. Well, that could be reduced. Divide by 3, right? So that would be 9 over 2. So I get 9 over 2. Now that's an ugly answer. I mean, what is that? That's going to be 4.5 is what x equals. So 4.5. Let's plug 4.5 in here and see if that works, right? So I have so if each of these are 4.5, let me change the color to blue. Let's see if that works. Count with me. We have 4.5 plus another 4.5. That would be 9, right? And then if I did another set of those, I went from 9 to 18. So we have 18 here. And then if I did another set of those, because you know, let me group these together. So this is 9, 18, 27. So this right here highlighted in yellow all equals 27. 27 plus 8. 27 plus 8 is going to be 27. Is going to be 35. So it does work. Hopefully this one's a little bit easier. Hopefully we don't get a decimal. This is a tape diagram. We have these unknown x's, but what we do know is that all of this together is going to equal 21, and we know that this extended part on the right equals 11. So if I wanted to write this as an equation, it would be, how many x's do I have? 1, 2, 3, 4, 5, 6. I have 6 x's plus that 11 up there has to equal the whole thing of 21. So the whole thing's 21. All right, so if I was to subtract 11 on both sides, I'm going too fast. Let me slow down. My variable is x. I got to get x by itself. And then I want to draw a divider on the equal sign. All right, so let's clean this up and see what we're left with. So we're left with 6x equals 10. We are going to be left with a fraction here or a decimal. What's the opposite of times by 6? Well, that's going to be divide by 6. So I'm going to divide by 6 on both sides. And I get x equals If I reduce that down, that would be the same thing as 5 over 3. Okay. All right. Well, I know for sure this tape diagram is going to clean up to be a lot better. This is called a hanger diagram, and the idea here is that the left side equals the right side. So I want you to think, okay, these things are equal in between here. Well, what does the left side equal? 1, 2, 3, 4, 5, 6, 7. So I get 7 equals, and what's the right side? We have 1 unknown, 2 unknown, 3 unknowns that are called W's. So because they're all, they all have to be the same, I'm going to call them 3W, and then it has that little extra 1 hanging off of it. So this is the equation. 7 equals 3W plus 1. Well, if these are equal, how much does one of these W's equal? Well, the idea here is when you're doing a two-step equation and you're subtracting 1 from both sides. So when I'm subtracting 1 to see what it is, you're actually canceling one of these off on each side. You're getting rid of them, so you don't have to worry about it. Well, what are you left with then? Well, you're left with 6 on this side, which is why when I clean it up, it's 6 equals 3W. So I'm thinking, all right, well, if 3W equals 6, how much does 1W equal? Well, you can kind of see visually, like those two go with that one. These two go with that one. And then this one goes with these two, right? So 1W equals 2. Well, what did I do? I divided it out. So that's why to undo multiply, I'm saying divide by 3. Ooh. Divide by 3 on both sides. So I get W equals 2. And that's what it should be. All right. I want you to pause the video and try to figure out what Z equals. So figure out what 1Z would equal. All right, so if you're back with me, you're looking at this, you're saying 2Z's plus the 3 equaled 5. So 1, 2, 3, 4, 5. And if you're going to subtract 3 on both sides, you'd be left with 2Z equals 2. Well, if 2Z's equal 2, well, let me slow down for a second. So we have, by subtracting 3, that's the idea of you're canceling out 1, 2, 3 on this side, and you're canceling out 3 on this side. So that pretty much is obvious now. If 2Z equals 2, then 1Z equals 1, right? Because when you divide by 2 on both sides, you're going to get 1. So Z equals 1 on this example. This is called a two-step equation because this is the first step right here by subtracting, and the second step is dividing. This was also a two-step because the first step was subtracting 1 and the second step was dividing. You're always going to be going back. You're always going to want to undo add and subtract first, and then you're going to want to do multiply and divide next. Okay, so let me skip to another example of just straight up solving. Alright, so we have x over 3 plus 6 equals negative 10. Alright, so where's my variable at? Well, my variable is right here. I got to get x by itself. So I'm going to do the opposite of plus 6. So I'm going to minus 6 on both sides. And I end up with x over 3 equals negative 16. So then the opposite of divide by 3, which is what this is going to be multiply by 3. So I'm going to times by 3 on both sides. Okay, so this is going to cancel out, and I'm left with x equals, well, a negative times positive is going to be negative, so it's going to be negative 48. Okay. Let's try another one similar to that. I want to get m by itself on this example. So I got to get rid of 8. So what's the opposite of plus 8? It's going to be minus 8 on both sides. All right, let's clean it up. I'm left with m over 4 I'm left with m over 4, Lucy. Lucy equals 11. So then I'm going to times by 4 on both sides. Sorry for my dog. Times by 4 on both sides, I get m equals 44. Okay. All right, now I want to show you one other problem, something with distribution. This is combining an idea you should have learned last year with what we just did. So if you see a problem like this on your con, I want you to distribute the 2 to each term in there. So when you do 2, when you're distributing, you're multiplying. 2 times x is going to equal 2x. 2 times negative 3 is going to equal negative 6. You only distribute to what's in parentheses. So the equals 14 just stays the same. And then you solve this like the examples we just did. You would add 6 to both sides. And you would be left with 2x equals 20. And then when you divide both sides by 2, because the opposite of times by 2 is divide by 2. When you divide both sides by 2, you would get x equals 10. Hey, let's plug that in and see if that's right. So I'm gonna clean that up real quick, and I'm gonna drop down 10 into here to see if that's true. So I'm thinking, all right, what if I replace x with 10? Well, 10 minus 3 equals 7, and then 7 times 2 does equal 14. So when I check my answer, it works. And then let's try one more together. You are going to distribute negative 3 to both terms in here. So you're going to get negative 3x, because negative 3 times x is negative 3x. And then this is kind of tricky. This is where a lot of kids make mistakes. You want to treat this as negative 3 times negative 4. A negative times negative equals a positive. So this is going to equal positive 12. That's probably one of my favorite mistakes. And then you don't distribute to the other side of the equal sign because it's not in parentheses. So I'm just bringing it down here. All right, so let's get rid of add and subtract first. So I'm going to subtract 12 on both sides. And I'm left with negative 3x equals, what's that, 57. And then I'm going to, well, what's the opposite of times by negative 3? The opposite of times by negative 3 is divide by negative 3. So I'm going to divide negative 3 on both sides. A negative divided by negative equals a positive x. and then this is going to equal a positive divided by negative is, I know my answer is negative, and it's going to equal 19, negative 19. All right. I know this is a few new ideas, so please reach out to me with email. We could set up Google Meets. We could do this stuff together. It's going to be important to keep up on your checkpoints. There's a good chance that I might just do the end of unit based on checkpoint completion. I still have to figure that out. But yeah, we're going to be on this concept next week too, guys. So, all right, reach out to me. Good luck.